So remote sensing has several unique advantages. Okay, for example, RS technology is well known as a non-destructive method to collect information about the Earth features. Uh, and then the data may be obtained systematically over very large geographical areas rather than just a single point observations. RS can be used to reveal information about places that are inaccessible to human exploration as well. And then uh, RS also have some drawbacks, okay, which number one, the quality data is not always optimal. Okay, and then second one, data errors and image distortion can result from internal and external sources. Okay, so for specific applications of remote sensing in agriculture, basically, uh, it can be used for monitoring of the land and crop physical parameters. For example, crop cover, crop health, and soil moisture. Okay, remote sensing also useful for operation such as stress mapping, fertilization, and pesticide application, also for irrigation management. Okay, and then for nutrient contents of different crop, okay, assessed using hyperspectral and multispectral remote sensing data. Okay, and then the interpretation of RS data is often aided by specialized technique such as geostatistic image analysis and classifications and artificial intelligence AI. Okay, when discussing and comparing remote sensing system and the image produced, there are at least four measures that need to be considered, which is spatial resolution, spectral response, spectral resolution, and frequency of coverage. Okay, for spatial resolution, this one refers to the size of the smallest object that can be distinguished in an image by produced by the remote sensing. Okay, this is how sharply focus of the image. Okay, for spectral response, this one is referred to the ability of sensing system to respond to and collect radiation measurement within a particular spectral band, because each object uh, is having their own response. Okay, for example, the wavelength for non-crop is different with the crop, or between texture of the soil. Okay, for sand, silt, and clay, the response for each of the texture is also different. So that one, but is what we call a spectral response. And then number three, spectral resolution. Okay, so for spectral resolution, refers to the ability of a sensing system to distinguish or differentiate between electromagnetic radiation of different wavelength, or we can say this resolution can describe the ability of the sensor to define fine wavelength intervals. Okay, the finer the spectral resolution, the narrower the wavelength range for a particular channel or band. Okay, so the higher spectral resolution, meaning that it can facilitate fine discrimination between different target based on the spectral response in each of the narrow bands. For example, if you have multispectral camera and hyperspectral camera, okay, multispectral camera can only differentiate between uh, durian and corn, okay, two different crops. But if you use hyperspectral, you can differentiate for durians example, the different variety of the durian, D24 and IOI. So in terms of accuracy, hyperspectral is better. And the last one is the frequency of coverage, okay, or also known as a temporal resolution. Okay, it is a frequency of how often a sensing system can be available to collect data from a particular site on the ground. Okay, based on time. Okay, vegetative index and normalized difference vegetative index, or VI and NDVI. Okay, vegetation index is one of the most popular and extensively studied products of remote sensing. Okay, it is used to predict and assess field crop characteristic. Okay, for example, plant leaf area, total plant material, and plant stresses. Okay, it is an index, an indicator. Okay, it gives you numbers and value. Okay, and NDVI is another product from VI. Okay, uh, that is very common use for remote sensing. Okay, by definition, NDVI is the ratio between two wavelengths, provides a comparison between two plants to determine which one is healthy and which one is stressed. Okay, so by formula, okay, NDVI equals to NIR, okay, minus rad, okay, divide by NIR plus rad. Okay, so the ratio between two wavelength, okay, one wavelength is NIR, near infrared, and the other wavelength is red band. Okay, NDVI value always range from -1 to 1. Okay, for example, if you have a negative value, it's highly likely that it is water. Okay, if you have NDVI value close to +1, okay, it is for dense crops. Okay, but when NDVI value is close to 0, it means that it's for sparse crops. Okay, there's not much green leaves, or you can say that it could be an urbanized area. Okay, for healthy vegetation, normally it will reflects more near infrared and green light compared to other wavelength, but it absorbs more red and blue light. Okay, this is why you can see the vegetation as the green color. Okay, while for unhealthy or sparse vegetation, okay, it reflects more visible light and less near infrared light. But overall, NDVI is a standardized way to measure healthy vegetation. If you have high NDVI values, then it shows that your vegetation is healthy. When you have low NDVI value, then you have less or no vegetation, or probably your vegetation is stress. Okay, and then uses of PA technology. Okay, so there are threefold use of PA technology. Okay, number one, for record keeping or data collection. Okay, farmer must keep records of the crop input and the fields. Okay, so this data can contain a spatial component. Okay, example for record keeping is soil sampling, yield mapping and monitoring, and also crop scouting. Okay, while for spatial analysis or data analysis and interpretation, it is the process of organizing, manipulating, querying, and summarizing the data in order to get more valuable information. Okay, and then the last one is for implementation. Okay, variable rate application. Okay, process of creating product to implement the information.